and then the cable really gave us trouble around 1.5, but it did so reproducibly. Again, we're just collecting the data, so not an issue. Up here, if we look at the force, okay, if I go ahead and zoom this out a little bit, you'll notice we have two pieces of data. They're almost identical, okay? They seem to be identical, at least noise-wise, but again, I would expect them to be almost identical because we didn't change the force. We didn't touch the 20 grams on the end of our little tiny hanger here. That was the same. So the force of the pool remained the same, but what changed was the mass. And if we closely examine our equation for kinetic energy, 1/2 the mass times the velocity squared, if we don't change the force times distance, which is the amount of work, but we do change the mass, we're probably going to change in the actual velocity of what's happening. We can see there in run 1, the velocity was way up here, and in run 2 the velocity got slower because it is a heavier item, because we've added mass to our little stack, but we're pulling with the same amount of force. It just went more slowly. Okay, kind of cool. Awesome. So let's see what kind of data that we want. I know we're not finished yet. I think I have to ask the computer to do a couple pieces of data here. Press the sigma button. Did that last time. Press the sigma button. Great. And again with the min and the max and the mean. Okay. Oh, but this time we want min and max and area, not min and max and mean. So I'm going to go ahead and grab this. And I also want the area. So I'm going to click this guy down here. We also want the area. So you'll notice what happened on the screen is it's actually calculating based on both of these graphs. In fact, right now, just run 1. It calculated if you took this purple data and you calculated the area under the curve, it looks like a rectangle. Okay, so this data here is sort of the bottom of that rectangle. This axis is the top, and this is just a straight line. If we do the same thing and select the green down here and press make sure that we get area. Now we have both areas. We have areas for run 1, which is that guy, and area for run 2. Notice this guy had a little malfunction there and got more area. It's just calculating what is the area underneath the curve, if you will, or inside this box, even if this particular side of the box is all noisy and goofy. Okay. We did that. Press beautiful. Place check on the max and min. Oh, we did that. Min and max. Yep. Fantastic. Using the values of mass for each of the items, mass of the cart and force sensor is 0.825. That's what that guy is. Mass of the bar is 0.5, and mass of the hanger and the mass of 0.25. Mass of the 20 gram mass. The mass of the hanger, we know again. I need my red pen. Here's our guy. So the mass of the hanger and the 20 gram mass, of course, was 0.25 kilograms. And because it's then 0.025 kilograms. The mass of the cart and the payload was this. The first time around was just that guy, 0.825. And the second time around, we added 5 to that. So I think 8 plus 5 is 13. Is that right? Yep, I think that's right. So it's 1.325. The area under the force versus position, which is this guy, the first time around it was negative 0.19. And the second time, oh, look at that, it's the same, negative 0.19. And then we have the minimum velocities and the final velocities. What that means is this is the start velocity when it was here at 100, and this is the final velocity when it was way down there at 1.8. So on the first run, the min velocity was 0.12 meters per second, and the max velocity was 0.54. And then the minimum was 0.10, a little bit slower, and 0.42, a little bit slower. So we know the initial and final was slower the second time around, but again, if we know what kinetic energy is in 1/2 mv squared, we expect that velocity to be a little slower because this entire stack was a little heavier. That's kind of cool. Fabulous. Everything after here is calculating more information that deals with a change in kinetic energy, and there's some more questions back here. So I believe that we are finished with the data acquisition. So that's kind of cool. So I'm going to grab all of this. And it turns out this is the last time that we're going to use the cart with the string and the pulley. It's been very useful for us. We've done it with a couple experiments now. Well, again, what we've done is we've changed how we're describing things. We still have some more experiments with this cart and the force sensor when we come back and do this when we do module 2C, and then one after that as well. So again, all we're going to do is we're going to increase our vocabulary and add even more concepts that physicists use in our toolbox to make these things, make us have more vocabulary to describe what's going on. But for now, it looks like this was a pretty huge success, and we're ready to go. So let me go ahead and stop this, and then we'll go back and take a look at this data. Cool. Thank you much.